Nothing lasts. Set a glass of lukewarm water on your table. Watch it. You will not see the water spontaneously separate, half of it heating up, half of it freezing into ice. That never happens. Not once. Not anywhere. Why doesn't it? The answer tells you why time flows in only one direction. And it points to the same universal fact that Buddhism, from a very different starting point, names as anicca, impermanence, tonight. Two independent investigations of the same universal fact, nothing lasts, arriving from very different directions. And then, two different responses to it. Begin with that glass. Hidden inside an ordinary question, why heat only flows one way, lives the mechanism that gives time its arrow. The reason nothing in physical reality maintains its structure without energy flowing through it. Modern physics traces this to the second law of thermodynamics. Buddhism, arriving through direct observation rather than physical measurement, calls the same fact anicca, and treats it as the first step of a path. Two investigations, one fact, different responses. This is the meeting point. Episode 2, Nothing Lasts. Chapter 1. Think about that glass again. The one on your table. Room temperature, lukewarm. You already know what happens if you drop an ice cube into it. The ice melts. The water cools slightly. Given enough time, everything settles into a single lukewarm mixture. But hold that image in reverse. Ordinary lukewarm water separating on its own. Half of it heating up to become hot water. The other half freezing into a solid cube of ice. Same glass, same molecules. Nothing added, nothing taken away. No one has ever seen this happen. Not because it's forbidden by any law about matter or energy. If you count atoms, the reverse state is possible. Energy is conserved. Mass is conserved. Every fundamental particle interaction that happens forward can, in principle, run backward. And yet, you have never seen ice spontaneously form in a glass of lukewarm water. Neither has anyone else. The universe is 13.8 billion years old, and this direction of events has been consistent throughout. That never, that direction that only points one way, is what physicists call the arrow of time. The person who first framed this precisely was a Prussian physicist named Rudolf Clausius, 19th century. Working in the aftermath of the Industrial Revolution, when steam engines were reshaping economies and physicists were trying to understand exactly what heat was doing inside those engines, in 1865, Clausius coined a word for the quantity that always increased when heat moved. He took it from the Greek, trope, transformation. He prefixed it to echo the word energy. The new word, entropy. His formulation was simple. In a closed system, heat flows from hot to cold, never the other way. And every time this happens, entropy, a measurable quantity, increases. This is the second law of thermodynamics. It is unlike any other law in physics. Newton's laws of motion work the same forward and backward. If you film a billiard ball breaking a rack, then reverse the film, the reverse looks strange to your eye. But it doesn't violate any law of mechanics. Every collision is time-symmetric at the microscopic level. Maxwell's equations for electromagnetism, time-symmetric. Even quantum mechanics, reversible. The second law is the exception. It is the only fundamental law of physics that knows the difference between past and future. The natural question, why? Why should this one law behave differently from all the others? The answer took another generation to work out. and it required someone willing to think about the universe in a way no physicist had thought before. Ludwig Boltzmann was born in Vienna. His answer to Clausius's puzzle was, in one line, this: entropy doesn't increase because a law commands it. Entropy increases because there are vastly more ways for things to be disordered than there are for things to be ordered. Think again of the glass. If you could zoom in and watch each water molecule, you would see them bouncing off one another at high speed. Trillions of molecules. Each has a position and a velocity. The macroscopic state you observe, lukewarm water, is one arrangement out of an unimaginably large number of possible arrangements those molecules could take. Now, how many of those possible arrangements correspond to lukewarm water throughout the glass? Nearly all of them. How many correspond to hot water in one half, solid ice in the other, spontaneously separated? A number so small compared to the first that we can, without exaggeration, treat it as zero. Entropy, in Boltzmann's formulation, is a measure of how many microscopic arrangements correspond to the macroscopic state you observe. His equation for it took a form so compact, he later chose it as his epitaph. S equals K log W. Entropy equals a constant, times the logarithm of the number of possible arrangements. The second law, then, isn't a law that forces the world in a particular direction. It's a statement about probability. Systems don't move toward higher entropy because they must. They move toward higher entropy because of all the possible things that could happen next. The higher entropy outcomes are so overwhelmingly more numerous that any other outcome would require what amounts to a statistical miracle. Time's arrow in this picture is entropy's arrow, and entropy's arrow is the arrow of statistical probability. Boltzmann spent the last years of his life defending this insight against physicists who did not yet believe atoms were real. His most powerful opponents, Ernst Mach, Wilhelm Ostwald, argued that his statistical mechanics rested on entities no one had ever directly observed. He died in 1906 in a small town near Trieste, believing his work had been rejected. Within a few years, Einstein's papers on Brownian motion and Jean Perrin's experiments on suspended particles had settled the question decisively. Atoms were real. Statistical mechanics was correct. His vindication came just after he was gone. Today, his gravestone in Vienna's central cemetery bears a single line: S equals K log W. Entropy doesn't lie. That was the 19th century. Come forward now 150 years to a working theoretical physicist named Carlo Rovelli. Rovelli is one of the founders of loop quantum gravity, a field that tries to reconcile Einstein's general relativity with quantum mechanics. In 2018, he published a book called The Order of Time. It's a book about what physics does and does not know about the nature of time itself. His central claim, which builds directly on Boltzmann, is this. In his own words, in the elementary equations of the world, the arrow of time appears only where there is heat. The link between time and heat is therefore fundamental. Every time a difference is manifested between the past and the future, heat is involved. In every sequence of events that becomes absurd if projected backward, there is something that is heating up. Read that carefully. He is saying that at the deepest level, physics currently understands, the level of fundamental equations describing particles and fields, there is no direction of time at all. The past and the future are equally real, equally accessible, mathematically indistinguishable. The direction we experience, the felt sense that time flows forward, enters physics only through entropy, only through heat, only through the statistical asymmetry that Boltzmann worked out, which means The past is different from the future for exactly one reason: because entropy has increased between them. At this point, you might be asking the obvious next question. If entropy only increases, if the universe has been running down for 13.8 billion years, where does it end? The theoretical endpoint has a name. Physicists call it heat death, a state of maximum entropy throughout the universe. No temperature gradients, no available energy for work, no ordered structures anywhere. Everything at the same lukewarm temperature forever. Several caveats belong here. First, this is a projection on a timescale so long, it renders the current age of the universe a rounding error. 10 to the 100 years. A 1 followed by 100 zeros. The current universe is still, by any reasonable measure, in its early morning. Second, the universe is currently expanding, and that expansion is accelerating. Some cosmologists question whether a universe with accelerating expansion is even the right kind of system for classical heat death arguments to apply. The question is genuinely open. Third, heat death is a leading hypothesis, not settled consensus. What is not in question, what physicists across every school agree on, is the direction. Entropy increases. Time has an arrow. Whatever the ultimate fate of the cosmos, right now, at this moment, in this glass on your table, in your body, in every ordered structure anywhere in the universe, nothing maintains its structure without something else paying the cost. Which brings us to a beautiful complication. If entropy only increased, if the second law only destroyed structure, the universe should have flattened out long ago into thin, uniform gas. No stars, no galaxies, no planets, no life, no listening to this, no thinking about it. And yet, here we are, sitting inside a body that maintains itself, looking at a glass that holds its shape, watching a candle burn steadily on a table, living in a world absolutely full of temporary, ordered structures that persist for seconds, hours, years, sometimes millions of years. How? The answer came in 1977 from a chemist named Ilya Prigogine. He received the Nobel Prize that year for showing something that had been hiding in the mathematics of thermodynamics all along. Entropy does not only destroy structure. In systems that are open, systems through which energy flows continuously, entropy can also create temporary structure. Prigogine called these systems dissipative structures. A flame is a dissipative structure. It imports chemical energy from fuel. It exports heat and light. As long as fuel continues to flow, the flame maintains its recognizable form, that flickering teardrop of light, for as long as you like. When the fuel ceases, so does the flame. A whirlpool is a dissipative structure. The water flows through it. The pattern remains stable until the flow changes. A living cell is a dissipative structure. It imports nutrients, oxygen, water. It exports heat, carbon dioxide, waste. As long as this flow continues, the cell maintains its extraordinarily ordered internal state. When the flow stops, so does the cell. Your body is a dissipative structure. Every day, food in, waste out. Air in, air out. Water in, water out. The pattern that is you persists because energy flows through you. Stop the flow, even briefly, and the pattern begins to unravel with striking speed. Prigogine's insight, in one line: the temporary order we see everywhere in the universe is possible because entropy is being produced elsewhere. Structure and dissipation aren't opposites. Structure is what dissipation looks like when it flows through an open system. The second law hasn't been violated, it has been paid. Which brings us to a structural resemblance worth naming carefully. In Buddhist analysis, what we call a person is described as 5 aggregates: panca, khandha, form, feeling, perception, mental formations, consciousness. Not a self, not a soul, not a thing. A pattern of 5 interdependent processes maintained by conditions. Prigogine was not describing Buddhism. Buddhist teaching is not describing thermodynamics. These are 2 different discourses developed for 2 different purposes, arriving at their claims by 2 entirely different methods, but the structural resemblance is worth stating because it illuminates something that is otherwise hard to hold in mind. What Buddhism calls the aggregates and what Prigogine calls a dissipative structure are, from very different angles, describing the same category of thing, a temporary ordered pattern, maintained by the continuous flow of energy and conditions, which will cease when those conditions change. This is not a claim that entropy explains anicca, or that the khandha teaching anticipates thermodynamics. It is a claim, more modestly, that Prigogine's science gives us a physical framework for thinking about a category of thing, the temporary self-maintaining pattern that Buddhist analysis has been describing from the inside for 2,500 years. The physicist tells you what a candle flame is. The teaching asks you to consider that whatever you call you belongs to the same category as that flame. Not a permanent thing surrounded by change, a pattern maintained by change. When the fuel ceases, the flame ceases. There is a technical word in Pali for this cessation of the flame. We'll come to it in Chapter 3. For now, hold this in mind. Modern physics, arriving through measurement of matter and energy, has produced the clearest picture we have ever had of universal impermanence. Entropy names it. Boltzmann quantified it. Rovelli locates the arrow of time inside it. Prigogine shows us that even the temporary structures we care most about, living cells, human bodies, ordered systems of every kind, are produced by that same asymmetric flow. Nothing lasts, not because it fails, because that is what the physical universe fundamentally is. Buddhism, arriving by an entirely different method, made the same observation 2,500 years ago, called it anicca, and drew from it a conclusion physics never draws. Chapter 2. What the Buddha did with the fact that nothing lasts. Chapter 2. Boltzmann's equation was published in 1877. Clausius coined the word entropy in 1865. Rovelli's book came out in 2018. The Buddha lived, by the best current dating, in the 5th or 6th century before the Common Era. He did not have the second law of thermodynamics. He did not have statistical mechanics. He did not have Prigogine's dissipative structures, or Rovelli's arrow of time, or any picture of atoms or molecules or entropy at all. What he had was a body. What he had was a mind. What he had was the ordinary human capacity. The same capacity you have right now, to sit still and watch what actually happens in a single moment of experience. And with that, in his own account and in the account of the tradition that carried his teaching forward, he arrived at the same observation modern physics has since spent 2 centuries trying to measure. Not as a conclusion, not as a curiosity, as a foundation. First principle, starting point. The core teaching is preserved in a single line of verse. Verse 277 of the Dhammapada, the most quoted collection of Buddhist teaching poetry. In the translation of the American monk Thanissaro Bhikkhu, it reads, "When you see with discernment, all fabrications are inconstant. You grow disenchanted with stress. This is the path to purity. Read it slowly. Notice what is not in it. There is no claim about atoms. No claim about statistical arrangements of molecules, no cosmology, no prediction. What is there instead is a structure of practice. First, when you see with discernment. Second, all fabrications are inconstant. Third, you grow disenchanted with stress. Fourth, this is the path to purity. Each move follows from the one before, and the whole shape hangs on the meaning of that first move. When you see with discernment. We'll come back to that in a few minutes, because it is where the Buddhist teaching diverges most sharply from the scientific description of the same fact. But first, this verse does not stand alone. It is the first in a set of three, presenting what the tradition calls the three characteristics. Verse 277, all fabrications are inconstant. Verse 278, all fabrications are stressful. Verse 279, all phenomena are not self. Anicca, dukkha, anatta. These three form a logical sequence. Each follows from the one before. Something that is inconstant, that changes, that arises and passes away, cannot deliver a permanent satisfaction. If you rely on it for happiness, at some point it will change, and the reliance will produce suffering. That is dukkha, translated by Thanissaro as stress, the mental strain of clinging to what is inherently unclingable. And something that is inconstant and stressful cannot honestly be called self. A self, in the sense the Buddha's contemporaries meant, was supposed to be something permanent, something reliably yours, something with the power to make happiness stick. But if the aggregates that make you up are inconstant, if grasping at them produces stress, then whatever you take to be you does not have the properties a self was supposed to have. Anatta, not self. Three characteristics, one observation, different angles on the same fact. Now, the earliest and fullest exposition of this pattern comes in what tradition holds to be the Buddha's second teaching, delivered to his first 5 disciples in the deer park at Isipatana, shortly after the first. That teaching survives as the Anattalakkhana Sutta, the discourse on the characteristic of not-self. In the Samyutta Nikaya, section 22, Sutta 59, the core is a series of questions. The Buddha asks his monks about form, the physical body. In Thanissaro's rendering, is form inconstant? Inconstant, Lord. And is that which is inconstant stressful? Stressful, Lord. And is it fitting to regard what is inconstant, stressful, subject to change as, this is mine, this is myself, this is what I am? No, Lord. He runs the same exchange through feeling, perception, mental fabrications, and consciousness. Every aggregate that makes up experience, every one inconstant, every one stressful when grasped, every one not fit to be called self. That is the logical chain. Anicca leads to dukkha, leads to anatta. See one clearly, and the other two follow. Which brings us to the question the physicist cannot answer. If nothing lasts, if entropy has been telling us this for 150 years, if statistical mechanics can prove it, if Rovelli can trace the very arrow of time to it, why hasn't the mere knowledge of this fact freed anyone from clinging to what does not last? Ice melts. Your car depreciates. People age. At some level, that everything you love will eventually be gone, or that you will be. And yet you continue to build houses out of temporary things. You continue to arrange your life as though something in it will last. You continue, moment by moment, to be surprised by loss. Why? Because there is a difference. And this is where the Buddha's teaching diverges most cleanly from any purely scientific account of impermanence, between knowing something and seeing it. Knowing that things are impermanent is a propositional fact. It sits in memory. It can be recited. It can be graded on an examination. It affects behavior the way any belief affects behavior. Indirectly, filtered through habits and preferences that were formed long before the belief arrived. Seeing that things are impermanent is different. Seeing, in the Buddha's usage, paññāya pasati, seeing with discernment, is a first-person, moment-by-moment observation of change happening in your own experience. Not thought about, not remembered, not reasoned toward, observed directly as it is happening. This is the load-bearing distinction of the whole teaching on impermanence. The second law of thermodynamics tells you everything is impermanent. It gives you a proof. It gives you an equation. It gives you a mechanism. Verse 277 of the Dhammapada asks something different. It asks you to see, with your own attention in this moment, watching the sensations of your body and the movements of your mind. That impermanence is happening right now, not in principle, not in some future collapse of the universe. Here, in this breath, in this sensation, in this thought, the tradition preserves specific instructions for what this seeing looks like. In the Satipatthana Sutta, the establishing of mindfulness discourse, Majjhima, Nikaya 10, the Buddha describes it this way. The practitioner, seated in attention, remains focused on the phenomenon of origination with regard to the body, on the phenomenon of passing away with regard to the body, or on the phenomenon of origination and passing away with regard to the body. Origination, passing away, origination and passing away. Three modes of attention: watching things arise, watching things fade, watching arising and fading as a single continuous process. If you have watched our earlier discussion on the practice of direct observation, Vipassana, you already know what this looks like from the inside. If you have not, the important thing to hold in mind here is that this is a method, not a doctrine. Something to do, not merely something to believe. And when this method is developed, according to another sutta in the same collection, the Anicca Sanya Sutta, Samyutta Nikaya 22, Sutta 102, something happens that no propositional knowledge of impermanence has ever been reported to produce. In the translation of Bhikkhu Bodhi, when the perception of impermanence is developed and cultivated, it eliminates all sensual lust, eliminates all lust for existence, eliminates all ignorance, and uproots all conceit I am. Read that carefully. Not helps to reduce, not gives context for, not provides a philosophical framework alongside. Uproots, all the way down. The very sense of standing at the center of your own experience, saying, I am, and this is mine. That sense, that habit of self-location, uprooted by the sustained perception of impermanence. A related sutta, the Girimananda Discourse at Anguttara Nikaya 1060, lists the perception of impermanence as the first of 10 perceptions the Buddha taught for the well-being of a gravely ill monk. That is the sutta's stated frame, a teaching offered for the benefit of someone suffering. The perception carries similar weight across every context in which it appears, because it operates on the same underlying faculty, the direct seeing of what is arising and passing. So here is the shape of what Buddhism does with the fact that nothing lasts. Physics arrives at the conclusion, nothing lasts. The measurement confirms it. What you do with that fact, physics does not say. That is not physics' job. The Buddha arrives at the same conclusion by an entirely different method. Nothing lasts. Then he says, now sit down, watch your breath, watch a sensation rise and fall, watch a thought appear and dissolve. Do this until the fact of impermanence stops being a proposition and becomes something you are seeing directly. Do it long enough, and the mind that has spent its entire life grasping at what does not last will begin, gradually, to loosen its grip. That loosening is the beginning of the path. Same fact, different response. And it is precisely here that a further question opens. If the aggregates are inconstant, if grasping at them is stressful, if what you take to be self does not have the properties of a self, is there anything at all that is not conditioned? Anything that is not swept along in the same current of entropy the physicist has measured? Is there any exit at all from the pattern? That is chapter 3. Chapter 3. At the end of chapter 1, I mentioned there is a technical word in Pali for what happens to a flame when its fuel ceases. The word is nibbutta. It comes from a verb meaning to be extinguished. Specifically, the way a lamp goes out when the oil is exhausted. Not violently, not destroyed. Simply, the conditions that sustain the flame are no longer present, and the flame, which was never a thing but a process, is no longer occurring. The noun form of that same verb, applied to a person rather than a flame, is nibbana, extinguishing, unbinding, the going out. Hold that image for a moment, because the question chapter 2 ended on was, is there any exit at all from their pattern of impermanence? Anything not swept along in the same current entropy has been measuring? The Buddhist answer is subtle, and it needs to be stated with care, because it is easy to hear wrong. The answer is yes, and that yes is not a claim about physics. Now, before we get to what the Buddhist tradition means by that yes, let us first look at how modern physics handles the same question at its own limits. Return to Rovelli in the order of time, alongside his argument about entropy and the arrow of time. Rovelli makes a further claim that unsettles a great deal of ordinary intuition. He argues that the present moment, the now you feel yourself inhabiting right at this instant, has no special status in fundamental physics. At the level of the elementary equations, there is no universal now. There are events. There are relationships between events. There are gradients of entropy. The felt sense of a moving present, distinct from past and future, emerges, in Rovelli's account, from the specific way we, as thermodynamically situated observers, are coupled to those gradients. Our sense of now is not fundamental to the universe. It emerges from thermodynamics. If you have watched episode 1 of this series, you already know we have arrived at something like this once before. There we found that seeing is a construction, the brain's best guess about a world it never encounters directly. Reality, in episode 1's framing, is not what you see. Perception is fabricated. Now, in episode 2, even the felt sense of now, the pulse of the present moment, is, according to leading physics, an emergent construction, not a fundamental feature of reality. Two constructions, two meeting points, which raises a question the tradition has been holding for 2,500 years. If perception is constructed, and the sense of a moving present is constructed, and the 5 aggregates that make up what you take to be yourself are inconstant, and every ordered structure in the physical universe is a temporary pattern maintained by conditions, is there anything at all that is not constructed? Anything not conditioned? Anything the pattern of impermanence does not reach? The Buddhist canonical answer appears in a very small, very old collection of the Buddha's utterances called the Udana, the inspired utterances, specifically in verse 3 of the 8th chapter, which is called simply Nibbana Sutta. The verse is one of the most philosophically compressed statements in the entire canon. In Thanisaro's translation, There is, monks, an unborn, unbecome, unmade, unfabricated. If there were not that unborn, unbecome, unmade, unfabricated, there would not be the case that emancipation from the born, become, made, fabricated would be discerned. But precisely because there is an unborn, unbecome, unmade, unfabricated emancipation from the born, become, made, fabricated is discerned. Read that carefully. The Buddha is not offering a metaphysical proof. He is not describing a place, a state, a thing, a substance. He does not say what the unborn is. He says only that it is not born, not become, not made, not fabricated, and that because it is not those things, release from what is born and made and fabricated becomes possible. The whole utterance is defined by negation. Not born, not become, not made, not fabricated. The tradition has been careful ever since to keep it that way. Every attempt to say what the unconditioned positively is fails, because the categories of positive description, this thing, that thing, here, there, are themselves conditioned categories produced by fabricating minds. To describe the unfabricated in the vocabulary of the fabricated is to miss it. Thanisaro puts it as clearly as anyone. The Buddha's teaching about Nibbana is not a theory. It is what he called a raft, a tool for crossing. And the point of the raft is not to be examined and admired. The point is to reach the far shore. But notice what has happened structurally. At this meeting point, Chapter 1 traced physics to its clearest statement of universal impermanence. The second law. Chapter 1 traced Rovelli to a further insight, that even the flow of time itself is a thermodynamic phenomenon, not a fundamental feature of the universe. At that boundary, physics stops, not because physicists have run out of ideas, many are still working, but because the method of physics has structural limits. Third-person measurement, applied to physical systems, produces statements about physical systems. When Rovelli reaches the question of what the now of experience actually is, he can trace it to thermodynamics. He cannot step beyond that trace with the tools he has. And the deepest questions: is there anything not subject to entropy? Is there anything not conditioned? Is there anything that measurement cannot in principle touch? Those questions are, on Rovelli's own account, questions physics may never resolve. Chapter 2 traced Buddhist teaching to the same fact of impermanence from an entirely different direction. Direct first-person observation of moment-by-moment experience. At its own boundary, Buddhism also stops. Not because the Buddha ran out of ideas, because the object being pointed to, the unborn, the unfabricated, is by definition beyond conceptual formulation. Every additional word would be a fabrication, which is what the point is not. Two traditions, two investigations, two entirely different methods. Both reach a point where they cannot continue in words. And here, at last, is the divergence that gives Chapter 3 its name. Physics offers description, precise, verifiable, extraordinarily powerful description of what the universe does. It does not, and does not claim to, offer a path. Entropy will continue to increase. The second law will not, as far as any physicist can see, ever cease to hold. Rovelli's arrow of time will keep pointing forward. Prigoghine's dissipative structures will keep forming and dissolving. Every temporary pattern in the universe, including the one that is you, will eventually be repaid. Buddhism, arriving at the same fact of universal impermanence, does something physics does not do. It offers a path, it offers a practice, and it offers a specific claim about what the practice is for. Return to verse 277 of the Dhammapada. One last time. When you see with discernment, All fabrications are inconstant. You grow disenchanted with stress. This is the path to purity. The path, not. This is a fact about the universe. Not. This is an interesting philosophical position. Not. This is a proof, or a mechanism, or an equation. This is the path. The second law tells you that entropy cannot cease to operate on physical systems. That is not a matter of your effort or intention. The universe does what it does. You cannot vote against entropy, the fourth noble truth. The last of the Buddha's 4 foundational statements says something categorically different. It says that tanha, the craving that grasps at what does not last, can cease. That the cessation of tanha is not a hypothesis, but a possibility, and that the path to that cessation is describable, teachable, walkable. Entropy cannot cease. Tanha can. These are different problems addressed by different disciplines, requiring different responses. The physicist tells you what the universe does. The teaching tells you what you can do inside that universe. Which brings us back to the flame. Under the second law, every flame will eventually go out. Every candle burns down. Every star runs out of hydrogen. Every ordered pattern in the physical world eventually returns to the general drift of increasing entropy. Under the Buddha's teaching, the going out of the flame is not a defeat. It is not a failure. It is not entropy winning. It is the very image the tradition uses for release. When the fuel of craving ceases, the flame that is the burning process of self-making, the flame of a mind clutching at what doesn't last moment after moment, life after life, is no longer being sustained. There is nothing violent about it. There is nothing destroyed. The conditions that produce the flame are no longer present. The flame, which was never a thing but always a process, is no longer occurring. Nibbita, extinguished, not annihilated, not sent somewhere else, simply no longer fabricated. This is the answer physics does not provide, because it is not the kind of answer physics deals in. And it is the answer the Buddha spent 45 years teaching, because it is precisely the kind of answer his method, direct first-person observation of conditioned experience, was designed to reach. 2 investigations, same fact, different responses. One describes, the other offers a path through. That is the meeting point of episode 2. The close is next. Close the glass on your table is empty now, or if you set it there half an hour ago, if you have been listening at the pace this program moves, it has warmed slightly toward room temperature. The ice you never put in has never formed. It will not form. Not tonight. Not tomorrow. Not in the lifetime of the universe. That direction, that never, is what tonight was about. 2 investigations of that never. Rudolf Clausius watched heat move through 19th century steam engines and coined a word for what he saw. Ludwig Boltzmann worked out why. In mathematics so compact, he chose it as his epitaph. His gravestone in Vienna's central cemetery bears the equation still. S equals K log W. Entropy doesn't lie. Nothing lasts. Carlo Rovelli, in our own century, traces the very arrow of time to that same asymmetry. Every distinction between past and future, in every corner of the physical universe, ultimately grounded in the flow of heat. Ilya Prigogine showed that even the temporary structures we care most about, the candle flame, the living cell, the body reading this, are produced by the same asymmetric flow, not exempt from entropy, constituted by its passage. 2,500 years earlier, a man sitting under a tree in northern India arrived at the same observation by a different method. Not measurement, direct attention, watching moment by moment what actually happens in a single frame of experience. And what he found, he preserved in a single line of verse. When you see with discernment, all fabrications are inconstant. You grow disenchanted with stress. This is the path to purity. Same fact, different response. The physicist tells you what the universe does. The teaching tells you what you can do inside that universe. Entropy will not cease. But the mind that has spent its life clinging to what does not last, that mind can loosen its grip. Not because impermanence goes away, because you stop demanding that it not be so. That loosening has a name, Nibbutta, extinguished, like a lamp when its oil is gone, not destroyed, not sent somewhere else, simply no longer fabricated. The flame that was never a thing but always a process is no longer occurring. Boltzmann's equation guarantees that every ordered structure in physical reality will eventually be repaid to the general drift. The Buddha's teaching points towards something the equation cannot touch. In verse 3 of the 8th chapter of the Udana, there is an unborn, unbecome, unmade, unfabricated, not describable, not measurable, not reachable through the third-person methods that gave us the second law. Reachable, according to 2,500 years of first-person testimony, through a path the tradition has kept intact from the beginning. Two independent investigations of the same universal fact. Both arrive at impermanence. One traces its mechanism through equations. The other offers a path through it. Nothing lasts. The second law says so from the outside. The first characteristic says so from the inside. And the tradition that names it from the inside also names, carefully, what remains when the fabricating has ceased. That is the meeting point of episode 2. If you found tonight worth your time, episode 1, Reality is Not What You See, is available in the playlist. Each episode of the meeting point stands on its own. You do not need to watch them in order. If you have not seen episode 1, that would be a natural next step. If you have, sit with tonight for a while. The glass is on the table. Watch it. Watch anything. See what is arising. See what is passing. The path is not a place you reach. It is what happens when the seeing becomes clear enough.